right. Ethereum development today is pretty low level. Many engineers spend a lot of time doing gas golfing and writing assembly language to optimize the gas performance of their contracts. And this is actually pretty similar to programming bare metal on a regular CPU, which is great for performance, but is not as great for for managing higher complexity. And then once the contracts are done, engineers face another challenge, which is connecting their client with their contracts. Because every contract state is specific to the contract they wrote, they have to write their own specific network stack, have to set up some custom getter functions and custom event sourcing, and maybe a custom indexer to synchronize the client state with the contract state. And this is actually very similar to how web apps used to be built before frameworks were invented, where people had to set up their own REST API, write some SQL to write to a server, and then figure out their own state synchronizing logic to get the state from the server to the client. But then web frameworks were invented, and they added some conventions, and in turn, they made it much easier to manage the state. They added automatic API creation, and just in general made the developer experience much, much better. And the reason why web frameworks were invented is because this abstraction that they give helps to manage complexity. In today's world, if you want to write your contract completely in assembly, then that's great for performance, but you can't really manage a lot of abstraction or a lot of complexity in your app. And if you write your app with Solidity with a couple of libraries, you can already manage much more complexity, but there's still a limit that we currently have. But up until now, the limit wasn't really a big problem because gas cost on mainnet was already a limiting factor. So in fact, you couldn't even build more complex apps than the ones we've seen so far because of the gas cost. But with all the work that's going into L2s and rollups and data sharding and data availability, we hopefully will soon live in a world where we'll be able to build much more complex applications because we'll have much more gas that we can spend. But at that point, we'll need a framework to manage all of that complexity. And there's a reason why operating systems and web frameworks and game engines exist. Is because they abstract away those low-level complexities and allow for much more complex applications. All right, so we need a framework in Ethereum, but what would such a framework look like? That's the question that we asked ourselves 8 months ago, and we came up with MUD. MUD abstracts away a lot of low-level complexity. It gives some conventions over how to organize your data and components and your logic into systems, and then manages that low-level complexity such that you as a developer can focus on the features of your application. All right, so let's create an app with MUD. We can use the MUD CLI to start a new MUD project. This will set up the scaffolding and install the initial dependencies. And then once that's done, it's going to take a couple of seconds. Once that's done, we can start the development server and we're already good to go. Let's wait for the dependencies for a second. All right, this is going to start the development server and we're good to go. So MUD has a standard way of representing the data internally. And what that allows us is inside of MUD, we can build the entire networking sync, and we can sync the contract state with the client state by default without the developer having to waste a single brain cycle into networking code and setting up some getter functions and event sourcing. And the other great thing that a standardized data model gives us is data inspection on the client. We can actually provide developers with this dashboard by default that they can use to inspect their on-chain state. They can create some queries, click some buttons to create some queries, in fact, and then inspect and modify the data on the client, and it will automatically be synced with the contract. Let's see that in action. I'll first show you, or I'll first explain you what's going to happen so you don't miss anything. We have the client. It's going to send a transaction to the increment system, and that increment system is going to increment or modify a counter component on the contracts. And then MUD will take care of synchronizing that state with the client. And you won't see any confirmation popping up because we use a burner wallet in this case just to make the interaction more smooth. This is all the code that was necessary to set that up on the client. You don't have to actually read the code. It's just to show you that it fits all on one slide. And it also, most of this is just to visualize the state change on the client. The actual networking part is like 5 lines of code, and none of that is specific to the app. All right, so let's see it in action. We first start the networking, the development server, which will start the development node, start a client, and deploy our contracts to our development node. Then the browser will open up, and once that's done, we can now press the button, which in the background sends a transaction to the contract, and then Mud handles all the state change, all the state sync, and so we see the state change in the client without any manual networking code. Mud is also a permissionless framework. What does that mean? Let me explain you. As I already mentioned, logic and data is separated into systems and components. And then all of those systems and all of those components are registered in a namespace that we call a world. And it's registered with a fixed ID. So you don't have to address the systems or the components with a dynamic address, but rather with that fixed ID. And the great thing here, first of all, every system can read from every component in our world, but systems can only write to the components that they have write access to. And the great thing here is that third-party developers, or anybody really, can add new systems and new components to this namespace, to this world. And those new systems can read from all the components that are already there, but can only write to the new components or only to the components that they have access to. And the other great thing with this namespace, with this world, is that because we separate the logic and the data, it's extremely easy to update contracts. And also, not even the address changes because we address them using this fixed ID. So let's see that in action. Again, I'll show you real quick what happens so you don't miss anything. We have the increment system. We're gonna change some logic inside of the increment system, and Mud will figure out, or Mud will realize that the logic has changed, and in the background, redeploy that contract, upgrade that contract, but the state will stay the same. So let's have a look. Here you see how the client calls the system with a fixed ID. And then here you see how the system uses a library to increment the counter, in this case by 1. And this is why when we press the button, transaction is sent, counter is incremented by 1. Now we change that counter or that increment from 1 to 10. Mud figures out in the background what has changed, redeploys the contracts, and when we press the button now, the transaction is already sent to the new contract and the counter is incremented by 10 without us having to do any like manual upgrading logic. And that is just a tiny glimpse into Mud. What we saw today here is the development dashboard, state synchronization, hot contract reloading, and shared contract state. But Mud comes also already today with message relaying, bit packing, optimistic updates, type generation, general purpose indexes, code generation, a plugin system, and an expressive query language. And there's other things that are grayed out here in this map, which are the things that Mud doesn't have yet, but we're actively working on. And the great thing with the framework is that if you use that framework and the framework gets more features, your app gets those new features for free. That is Mud, and that is my talk. Thank you.